In this video, you're going to learn how to build full-stack permanent applications with Arweave, Smartweave, Next.js, and Warp contracts. Arweave is a protocol that allows users to store data permanently for a single upfront fee. Arweave also introduced Smartweave, a smart contract protocol that allows developers to build permanent applications on top of Arweave. When you publish a Smartweave contract, the program's source code and its initial state is stored in an Arweave transaction. When a user writes an update to a Smartweave program, they write their inputs as a new Arweave transaction. To calculate the state of a contract, a Smartweave client uses the contract source code to execute the history of inputs sequentially. All invalid transactions are ignored. In doing so, Smartweave pushes the responsibility of validating transactions and calculating the states onto the users and the clients. This design unlocks powerful functionality that is not possible with other smart contract blockchains. For example, you can execute arbitrary amounts of compute without additional fees, there is no state bloat, and you never have to worry about gas optimizations. You can even go as far as to do machine learning directly on the protocol, both execution of the model and training. With Smartweave, you can also code your smart contracts in JavaScript, TypeScript, or Rust. There are a couple of challenges, though, with using this approach and building on the protocol directly. Complex smart contracts or contracts with a lot of transactions can take a very long time to process. This is where Warp comes in. Warp is a protocol built on top of Arweave meant to facilitate a better developer experience and user experience for Smartweave application development. Warp consists of three main layers. The core protocol layer is an implementation of the Smartweave protocol and is responsible for communication with the Smartweave smart contracts deployed to Arweave. The caching layer is built on top of the core protocol layer and allows caching the results of each of the core protocol modules separately. This allows users to retrieve data from contracts with a large number of state updates, but also offers instant transactions and contract availability and finality. The third layer is the extensions layer. It consists of a CLI, debugging tools, different logging implementations, and so-called dry runs, which are actions that allow to quickly verify the result of a given smart contract interaction without writing anything to Arweave. On their website, we can see additional information and documentation about the protocol. For example, here it says that data input has been optimized by building a sequencer which sorts incoming transactions. Sorted interactions are instantly delegated to the bundler network for guaranteed persistence on the Arweave chain. The output side has been improved through the creation of dedicated gateway, which indexes the transactions. This enables fast queries and efficient filtering of interactions, which in effect greatly reduces state evaluation time. Multi-node execution network listens for incoming transactions and automatically updates contract state. Now that we've been introduced to Warp, Smartweave, and Arweave, let's get started writing some code. The application that we're going to be building today is going to be a blogging/CMS type of application. In this app, a user will be able to create posts, update posts, and delete posts, and also read posts. So this is a good example to build because it's the boilerplate or base of a lot of applications that you might build in the real world. Typically, they call this a CRUD app, create, read, update, and delete. And in this example, building a blogging application, it's often a real-world type of example that you might use in your day-to-day. So to get started, we're going to be building and showing how to use Warp both on the server as well as the client. And with that, we're going to be building a Next.js application, but we're just going to put all of our code in this Next.js application, regardless if it's being run on the server or the client. So to get started, we'll go ahead and create a new Next.js app using npx create next app. And I will call this full stack Arweave. And I'm going to choose no for TypeScript because we're going to try to make this as concise as possible. And we'll go ahead and jump into the new directory and open this up in our text editor. And the first update that I'm going to make is to be going into the package.json and setting my project up for using ES modules. So I'll just go ahead and set that to type module, and now we can use ES modules. And the next update we want to make is in our next.config. And instead of using module.exports, we want to say export default. And this is essentially moving this from CommonJS to ES modules. All right, so with that being done, we can close our next configuration. And we're next going to go into our git ignore and add a couple of files just to be safe. And the first one is going to be wallet.json. Now, we're not going to be using a wallet.json in this example tutorial, but I'm going to be linking to another tutorial where it shows you how to do that. And we want to make sure that you never actually push any types of wallet keys or anything like that to GitHub. So the first thing we want to do is make sure that we put that here. We also are going to be using, in this example, a test wallet. And this isn't really anything to worry about because it's going to be an example wallet that doesn't have any real crypto or anything, but it's worth just leaving off because there's no reason to push this to GitHub. And then the last thing is going to be this file that we're going to be creating later dynamically called transactionid.js. And this isn't anything too secret either, but it's just nothing that you probably won't push into GitHub because it's created dynamically mainly for testing purposes. So with that being said, we're done with our git ignore. We can go ahead and close this file. The next thing that we want to do is we want to go ahead and create an example Warp contract and execute it on the server just to show you how Warp works. And then we're going to go into the client application on the front end and re-implement some of this functionality with our Next.js and React application. So to do so, we're going to create a new folder in our root directory called Warp. And this is going to be where we put all of our Warp contract stuff. So the first thing we want to do is create a new file called contract.js. And this is going to hold our contract for Warp. And the general idea is you typically have this function called handle, and it takes two arguments. It takes the state and the action. The state is the existing state, and the action is any update that's being made to the smart contract. And this action will have arguments that you can kind of use. And pretty much at all times at the end of this function, you want to return the state in an object. So no matter what we are doing above this, we're always going to be returning the state. And then what we can do here is we can say if this or that or whatever, then we'll make some updates to the state. We'll say, if we do something, then we'll say, okay, state dot like name is equal to like something new. But essentially, you're going to be updating this state variable and then returning it here. For our example, though, we are going to be working with this state object that we haven't really looked at yet. So before we write the rest of our contract, let's go ahead and create that state object so we have a good understanding of what that would look like. So to do that, let's go ahead and create a new file in Warp called state.json. And here we're just going to drop in this JSON information that holds our state. So we're going to have a post object that's empty, and we're going to have an author field that's set to null. When we create the first post, we're going to set this author to the address that created it, and then we can do types of authentication and authorization and access control on who can update this state by checking to make sure that the updater is the same as the author. And then we can also make updates to the posts. Now, this could also have been an array, but I like working with this key value pair of an object better because it allows easier updating and access, in my opinion. So we're going to just go ahead and save that state. And now we know that we have this post object that we need to update based on what happens in this handler. So when an update happens to our contract, this handler is going to get called, and we're going to then make updates to that state like I mentioned before, and then we're going to return it. So the first thing we might want to think about are going to be what are the types of actions that might happen. So for a CRUD application, we might say we want to create, update, and delete. Okay, so with that being said or being understood, we might think about what are the things that are being created, updated, and deleting. And in our case, since we're creating a blog, we might think of blogs and posts. So we might consider, okay, we want to create a post, update a post, and delete a post. So what I can say here is if the action.input.function is equal to create post, then I want to, then I want to do something here. Whoops, and I'm using the wrong, there we go. So we have if the action.input.function equals create post, we're going to do something. And this is going to be our logic for creating a new post and updating our state. But we also might want to consider the identity and access control to make sure that only the people that can create a post are the one that actually has control of this application. And therefore, we might want to have another original action that is something like initialize. And this initialize action can then go ahead and set the author to be the caller. So we're going to go ahead and create another if statement here that says if action.input.function equals initialize, then we're going to say state.author is equal to action.caller. So we're going to say that we have a state.author, and we also would later have state.posts. And then we have this action object, and one of the properties on there is the action.author. I'm sorry, the action.caller. And the action.caller is where we're going to be setting the state.author. So what we can do at this point is we can say if the function is is create posts, and the action.caller is equal to the state.author, then we will make a state update. Because we only want to make a state update if the caller is the same as the author. So what we're going to do is we're going to get a reference to the posts. So we're going to say const post is equal to state.posts. We're then going to say the posts using the action.input.postID, which should be a unique identifier, is going to be the post that comes in. So then our data model, goes from being like this to I guess I'll leave this like this, but it might be something like, okay, post with the ID of 1 has this post data, because this is the post ID that's coming in. Okay, so with this basic functionality, we've implemented a create update. Now, what we need to do now is set the state to this new post object to finish this off. So what I might say is state.post is equal to post, and then we're returning the state. Now, with this same idea, we want to implement the same functionality for update and for delete. So I could actually use the same exact logic here where I'm saying if the action.input.function equals something and we have the action.caller is equal to the state.author, then we can make an update. And in this case, we're going to say update post, And then the last one is going to be delete post. Now for update post, we're going to be taking a similar type of action as when we create a new post. We're going to first get a reference to the posts. We're going to then get a reference to the post that's coming in. We're going to then update the post ID that's coming in and then resetting the state. So we're basically assuming that the updated post has all of the post information, and we're just taking an existing post and updating that information. Now for deleting a post, it's actually going to be fairly simple. We're going to first get a reference to the posts by checking and getting the state.posts. We're going to then delete the post using the ID that's coming in from the action.input.postID, and then we're going to reset the state, and then we're going to return the state. So we've now implemented an initialize action that sets the author and enables us to do identity and access control. We then have a function for creating a post or logic, I would say, for creating a post, logic for updating and for deleting. So that was quite a bit, but we are now done with our contract as well as our state. So what we want to do now is next create a file that will allow us to interact with Warp by configuring that Warp SDK. To do so, let's go ahead into our terminal and go ahead and install all the dependencies that we're going to need for this project. So I'm going to be using Yarn, but you can use npm or pnpm or whatever you would like. So the first thing we're going to install is Warp contracts. And this is the JavaScript SDK for interacting with Warp. We're also going to install React Markdown. This will allow us to render Markdown if the user uses Markdown in their input for creating a post. And then we're going to also install UUID, which will allow us to dynamically generate unique identifiers. All right, so once our dependencies are installed, we can go to our package.json and see that we have now React Markdown, Warp contracts, and UUID. So we can now move on to the next part of our application, which is going to be configuring that Warp SDK. So I'm going to create a new file in the Warp contracts folder called configure warp server.js. And here we're going to go ahead and import the Warp factory from Warp contracts. And this is going to allow us to interact with Warp. We're also going to import fs from fs. And this will allow us to interact with the file system. Next, we want to go ahead and create an environment variable. And we're not going to be setting this environment variable, but we want to have it available if we do in the future for mainnet. But by default, for this example, for this tutorial, we're going to be working with testnet. But if you wanted to set this Warp environment, you could do that either from your command line or from your shell configuration. And then we want to go ahead and create a variable called Warp, and that's going to be set to null for now, and later we will be updating that variable. And what we can do is now we can check for the environment, and if it's a certain environment configuration, we can set what Warp is. Okay, so we're going to have two types of configurations that we can have here. We're going to see if the environment is equal to testnet. If it is, we want to go ahead and create the Warp factory for testnet. We'll say Warp is equal to warp factory.forTestnet. Next, we're going to check if the environment is mainnet. If it is, we're going to set Warp as Warp factory for mainnet. And if not, we're just going to throw an error that says the environment was not configured properly. So at this point, Warp should be configured either for testnet or mainnet, depending on our environment variable. Next, we want to go ahead and create a function for configuring our wallet. And we will just call this function configure wallet. And what we want to export from this file is this configure wallet function and also Warp. So now we need to go ahead and create our logic for configuring the wallet. And what I'm going to do is set a try catch block here. And if there's an error, we'll log out the error. If not, we're going to go ahead and try to configure our wallet here. So what we're going to first check for if the environment is equal to testnet. We're going to take some action. And if not, we will be taking a different action. So if the environment is set for testnet, what we're going to do is we're going to go ahead and try to check and see if there is a local test wallet. And if there is, we're going to use that. And if there's not, we're going to create a new test wallet. So this is going to look like this. We're going to say, first we want to check if there is a file available called testwallet.json using the file system.read file sync. If there is, we're just going to return that to the caller of this function. If not, we're going to be using this warp function called generate wallet, which will allow us to dynamically generate a test wallet. And then we want to write the contents of that wallet to this file called testwallet.json. And then we also want to return this to the caller. If this is not testnet, we can assume that we are on mainnet. So what we can then do is we can check and actually just return the contents of a file called wallet.json that we are not going to be using in this video tutorial, but I'm going to be linking to a tutorial where it is available. So with all that being done, we should be good to go on configuring our server and our wallet. And what we can then do is import this configure wallet function whenever we need a wallet. And whenever we want to talk to the Warp server, we can just import this Warp variable and be ready to go. So with that being said, we want to be able to now deploy our contract using this configure Warp server and using the contract that we just created and the state. So I'm going to create a new file called deploy.js. And here we're going to go ahead and write our functionality to deploy. So first we're going to import the file system. Next we're going to go ahead and import configure wallet and warp from the configure warp server that we just created. Next we're going to create a function called deploy, and then we're just going to invoke that function. So what I'm going to first do is I'm going to go ahead and get a wallet by calling the configure wallet function that we just created. Next, I want to read the contents of our state.json. So I'm going to say fs.readFileSync, and I'm going to store that in a variable called state. Next, we're also going to read the contents of our contract and store it in a variable called contract source. And now what we can do is we can call warp.createContract.deploy. And here we're going to be passing in the wallet, the initial state, and the contract source. So this is the function that is going to actually deploy our application. And here you can see that we're passing in the wallet, the initial state, and the contract source. And this is going to return to us a contract transaction ID. And what we want to do is store that in our local file system in a new file. So I'm going to say fs.writeFileSync. I'm going to create a new file called transaction ID, and then that is just going to contain an export variable for that new contract transaction ID. And this will just make it really easy for us to import later on in our app. So what I want to do now is use that new contract deployment that we just created, and I want to call the initialize function to write our first contract interaction. So what I can do now is get an instance of our contract by calling warp.contract, passing in the contract transaction ID, and then connecting it with our wallet. And then we're going to call contract.writeInteraction, and this is going to write that first interaction into our contract. And the function that we're going to be calling is initialize. So again, if we go to our contract, you'll see that we have that action.input.function if it equals initialize. Here you can see that we're setting the function value as initialize. So that function should go ahead and update the state to set the caller as the author. Next, we're going to go ahead and call contract.readState, and this will give us an idea of what the current state looks like, so we can then just log it out. And what we're going to do is we're going to log out the contract state as well as the contract transaction ID. And this is going to be a nice way to deploy our contract and then read what the value of it is. All right, so that's all we need for deploy, and I'm going to go ahead and close these two files. The next things that we want to do are create functions for reading and updating the state. So we want to be able to read the current posts and create a new post. And again, we're kind of just testing things out in the server right now. So some of this stuff might be hard-coded, but we're going to be dynamically enabling this in our React application in just a moment. But for now, I'm going to go ahead and create a new file called read.js. And here we're going to go ahead and show how to read from our smart contract application. So the first thing I'm going to do is go ahead and import Warp and configure wallet again from our configure Warp server. Next, I'm going to go ahead and import the transaction ID. We're going to have a function called read, and then we're going to go ahead and invoke that function here. So in read, we don't really need to do a whole lot. First of all, we want to get an instance of our wallet. We then want to go ahead and create an instance of the contract here by calling warp.contract, passing in the transaction ID, and then connecting with our wallet. We want to read the contract state. So we're going to say await contract.read state. And then we just want to log this out because we want to kind of see what the value of that is. So I'm going to say console.log contract state, and we're going to stringify the value that's returned from Warp. So this is all we need to do to read the value of our contract, the state of our contract. And then finally, we want to create a file for writing. So I'll say, call this createPost.js. And this is going to be how we create a new post. So again, we're going to import Warp and configure wallet as well as transaction ID like we've done the past couple of times. We also want to create a unique identifier. So we're going to import the UUID library, the v4 function of that, and we're going to be using that to create a unique identifier for our post. Because when we create a post, we want to be able to pass in a unique ID for each post. And then I want to invoke this function, and we can now go ahead and write some code here. So like we did the last couple of times, we want to go ahead and get an instance of both the wallet and the contract. So I'll say configure wallet, and then also get a variable called contract so we can interact with the contract. And then now what we want to do is say contract.write interaction. And this is where we just pass in the values that we want passed in as the arguments. So in this case, we're going to say await contract.write interaction. The function is going to be createPost. So going back to our contract, we're looking for the function createPosts. And we're going to be passing in a post object that has a title, content, and ID. And remember, we were looking at the action.input.post.id. That's what this ID right here is. That's coming from our UUID. So you see that relationship between the write interaction as well as the contract, hopefully just there. And that's really about it. After we call this createPost function, we can then call the read function to see the current value of the state. So we've written all the code. Let's go ahead and try to test this out. So to do so, I'm going to go to my command line, and I'm going to run node deploy from the Warp contracts directory, from the Warp directory. And we can see if this works. If everything went good, then you should see that the contract ID is logged out as well as the state of the contract. And that should be exactly what it is here, posts and author set to null. So now if we go ahead and read the state of the contract, you'll see that we have everything set up. The author has been set as the person that deployed, and our current state is set to nothing, just an empty object. So what we want to do now is say node create post, and we want to go ahead and try to create a post. So here we have the post information. This is my first post, hi for my first post, and the ID. And now for the moment of truth, we want to run node read.js again and see if that new post is now in our state. And there we go. We see that the contract state has the new post there and everything is working as we expect. So now that we have our basic functionality set up, how can we kind of get more visibility into what's going on? Well, there's a block explorer that we can check out that's specifically for Warp applications. And to check that out, actually, we can go to sonar.warp.cc and we can go ahead and find the contract transaction ID for our contract. Go ahead and copy that to our clipboard here. And we can paste that in here. And here we can see information about our contract. And once the state has been evaluated, we should be able to click state and see information about our contract deployment. Now that we've got Warp working on the server, let's go ahead and continue building out our application on the front end, on the client. And to do that, I'm going to go back into my text editor and we're going to go to the root level of our application and we're going to create a new file called configure warp client.js. And like configure warp server, we want to have a configuration that we can also use on the client to interact with the Warp SDK. So I'm going to go ahead and import the Warp factory from Warp contracts like we did before. I'm going to go ahead and import that transaction ID from the deployment that we just created. And since we're still using our test wallet, I'm going to go ahead and import a reference to that. But we're also going to have configuration that allows you to continue building on mainnet if you would like by checking to see if there's a Warp environment variable set to mainnet. And if not, we're going to default to the environment being testnet. We're going to create two variables, one for Warp and one for contract. And then depending on the environment, we're going to set that in a function called getContract. We'll go ahead and export that at the end of our file. So what we want to first do is check if the environment is testnet. And if not, we want to check if the environment is mainnet. And if not, we want to just maybe throw a new error that the environment isn't set properly. So if we're in testnet, we're going to go ahead and set Warp to be Warp for testnet. And then we're going to set the contract to be warp.contract, passing in the transaction ID and connecting through our test wallet. But if the environment is mainnet, what we can do with the Warp SDK is actually just call warp factory.for mainnet, and then we can just say .connect, and this will automatically allow the user to connect their client wallet, which would be something like RConnect, in their application. So this would prompt them to actually, similar to how MetaMask would work, it would allow them to use their client wallet. And then from here, we just want to return the contract, because at this point, the contract is set to either testnet or mainnet. And then when we call getContract, we'll just be returning the contract, and then we can then make contract calls. So now that we have that created, let's also create a new file in our pages directory called create post.js. And similar to create post on the server, what we want to do is create a state update on the client. So what we're going to first import is use state from React to create local state. We want to call getContract from configure warp client to go ahead and get the contract configuration that we just created. We're going to be needing to create a unique identifier, so we'll import UUID, and we'll also import use router from next router. Next, we'll export the default function for our React component. And here we want to go ahead and create some initial state. So we want to have a post object set to title and content. And this will allow the user to type in the title and content. Now you notice in our Warp server here on create post, we have a title and a content and a UUID. And the title and the content were hard coded. In this front end application, we want to allow the user to actually type that into a form. We're also going to get a reference to use router or to the router, because what we want to do is say that after the user creates a new post, we want to redirect them to the index page of the app so they can view the list of posts. And the only function in this component is going to be create post, and this is going to be where we actually call the Warp contract. And then finally, we just want to return some UI that we're going to be creating in just a moment, and then we're also going to have some styling as well. So in our create post function, the first thing we're going to do is check to make sure that they've entered either a post title or both the post title as well as post content. And if they haven't, we just return. We then set the post ID to be a UUID. And maybe I'll just do that for now so we don't get that error. For the post ID, we're going to go ahead and set a UUID. And then we're going to get a reference to the contract by calling get contract. And then we'll just do a try catch block for calling the contract. So similar to what we did before, we want to call contract.writeInteraction, the function being create post and the post being the post off of our state. And then we want to console.log that result. And then we're going to call router.push to reroute us to the root of the app. And that's really all we need to do. So now we can attach this create post function to a button within our application. And we're going to be creating some styling later, but for now we're going to be referencing that styling. So here we will go ahead and return a div with the styling being form container style. Next, we want to have an input, and this input is going to be for the post title. So we're setting the value to post.title. We're setting the placeholder to post title. And then when the user types in the value for their post title, we're going to call update post, which updates the post state here. And what we want to do here is basically return whatever is already there and then update the title. And this is just a quick way to kind of update the state without having to have two separate state variables for post or for title or for content. And for the post title, we just have a typical normal input field. But for the actual content, we're going to give them a larger text area. And here, since we have that React Markdown editor, we'll allow them to put Markdown there as well if they would like. And then we can render that later. The value is going to be post content. Placeholder is going to be post content. The onChange handler is going to be very similar to this one, except instead of it setting the title, it's setting the content. And then finally, we have a style called text area style. So now we have three styles, one for form container, one for input, and one for text area. We're going to create all of those in just a moment. Finally, we want to have a button to call the create post function. The button is going to say create post. It's going to be connected to the create post function on click, and the styling is going to be button style. We're going to just drop in some basic styling here. For the form container style, we're going to set the width to 900 pixels, the margin to center, which is 0 auto, flex direction column, and align items flex start. For the input style, this is going to be for the small text input. We're going to set the width to be 300 pixels. We're going to set some padding. We're going to bump the font size up a little bit. We're going to remove the border and the outline, and we're going to set some bottom margin. For the text area style, it's going to be width 100%, height 300 pixels, margin bottom of 20 pixels, and padding of 20 pixels. And then finally, for the button, we're going to have a width of 200 pixels and padding of 10 pixels top and bottom, and 0 pixels left and right. Okay, so that's all we need to do to create a new post. The next thing we're going to do is create a file, or actually let's go ahead and update our index.js file. I don't think we need to create any more files. So instead of like using all of this stuff here, I'm just going to go ahead and delete everything for now. Or not everything, but most of everything. Okay. And now all we have right now is just this export default function home. Now what we want to do in this view is show a list of posts from our API, from Warp. So what we want to do is fetch those posts and set them in the state when the app loads. So in order to do that, we want to have useEffect to be able to call a function on load, and then we want to have useState to store the state updates in our component. We're going to import getContract from configure Warp clients, and we're going to import React Markdown from React Markdown, and this will allow us to render Markdown in our component. We're going to create a variable called posts and a function called setPosts set to an empty array. And then when the app loads, we're going to create a useEffect hook that will invoke a function called, I guess this will be an async function, called readState. So when the useEffect function the useEffect hook is triggered, it will call readState. ReadState is going to be the function that we're about to define now. So first we want to get a reference to our contract. So we'll call getContract. And then we're going to do a try catch block. What we want to do is call contract.readState. We're going to log out the data to the console just to see what it looks like. We're going to then get the post object and turn that into an array by calling object.values. And this essentially is a JavaScript method that allows you to take objects and turn them into arrays. And the data that comes back has a property called cachedvalue.state.posts. So the cachedvalue.state is the entire state object, and you can either get the post or the author off of that, and all we really need is the posts. And what we can then do is call setPosts and passing in the post array to replace the empty array. And then what we'll do is we'll just log out the posts as well. And this way we get a good idea of what this data model looks like. And it's probably helpful if you're new to Warp. Next, we want to set some styling on our main div. So I'll set this style to be something called container style, which we'll set up in just a moment. You know, the styling for this app isn't all that great. It's pretty basic because we're mainly focusing on functionality. I'm going to have an H1 with a title of permablog, and this is just going to let us set the title of our app. That could be whatever you want it to be. And then here we want to map over the posts. So here I'm going to say post.map, passing in, having having access to the posts as well as the index. Next, we want to return a div. Next, we're going to display the post title as well as the post content. The post title is going to be displayed using a paragraph tag, and the post content is going to be rendered in Markdown. And this will allow us to basically have the Markdown if someone uses Markdown. And it looks like I need to add one more parentheses here. And it looks like we are good to go there, I believe. And the last thing we want to do is go ahead and set the container style, the post style, and the title style. So we have container style here. That's going to be setting the width to 900 pixels as well as some centering the margin. We have the heading style. Heading style is just going to set a very large font size, in this case 64 pixels. For the post style, this is going to be the wrapper for every post. We're going to set the padding to be 15 pixels top, and we're going to set a border bottom of a very light white color. And then finally, we're going to have a title style. And this is going to be for the post title. Font size of 34 pixels and a 0 bottom margin to get rid of the default margin bottom. Okay, so I think that should be it. The last thing we want to do is set some navigation, because when the app loads, it's just going to render really this page. And we want to have a way to link to this new create post page. So to do that, we're going to open up _app.js, and we are going to go ahead and import the link component from next link. And instead of just returning the component here, we're going to return a div, which is going to be kind of like the wrapper. And we're still going to return our component down here, but we want to create some navigation as well. And to do that, I'll just create a nav component here. I will set some styling on the nav that we'll create in just a moment called nav style. And we're going to have two links. One is just going to link home back to the root of the app, which is kind of the index page. And this is just going to have a link for home. We'll have a link style that we'll create in just a moment. And then we want to have a link to create a new post. So we want to link to this create post page as well. So here we're setting the href as create-posts, create post. And only thing now we need to do is set that basic styling. So we have the nav style. Nav style is going to be padding of 30 and 100 pixels. And the link style is going to be separating the links from each other by just adding some margin right of 30 pixels. And I believe we should be good to go now. So what I would like to do is test this out. So what I can do to test this out is run npm run dev. And we're going to go to localhost 3001 because it looks like I have something already running on localhost 3000. And when the app loads, we see that we still have our hide from first post that we created earlier. So I want to click on create post. And here I want to say hello from Next.js. And I want to say this is my second post. And you can see that I'm using Markdown. I'm not sure how this Markdown is going to look because we haven't really added much styling for this, but we're doing a little something. All right, so let's test this out by clicking Create Post. And now we get navigated back to the main screen, and we now see that we have our new post there. And you see that the markdown is also being rendered because this is an H1. I believe this was like, an H2 or something like that. This was formatted as a callout, and then this is just regular text. So with that being said, we should be able to refresh and see that our data is coming back properly and we are good to go. So that's an introduction to both Smartweave as well as Warp contracts in a full stack application. I would recommend diving deeper into some of the Warp SDK documentation, example projects, Discord, and also building on mainnet and kind of getting a feel for that, because we've been doing everything on testnet. It's often cool to build something out and try something on mainnet as well. Just remember never to send your keys to GitHub. So that's it for this video. Thank you so much for checking this out. If you like this, share it and subscribe to my YouTube channel, and keep an eye out for more content in the future.